So we'll see what are these associative arrays. So before that, wait a minute. Let me check whether have started the recording. Yeah, I've started the recording. I hope you have watched the previous recordings. That is the dynamic arrays and the queues in the system verilog. So if you watch those recordings, then it will be easy to understand this particular concept, associative arrays. Okay. So yeah. So before going to associative arrays, we will once discuss about the previous topics, that is the dynamic arrays as well as queues and the packed arrays. We'll just see a brief overview of what are this we have discussed previous also. So coming to the packed arrays, can you tell me what are these packed arrays? Whether the size of this packed array is fixed or it is variable? First, we will discuss about the size parameter. Okay. Uh, Whether the size of this packed arrays is it fixed or it is variable? Can anyone answer this?
In packed array is fixed. In queue it will be variable. In dynamic also it
Right? It is variable.
variable.
Yeah. And coming to declaration, where we will declare this packed arrays, whether it in compile time. Okay. Sorry. Where the size is allocated to the packed arrays, whether in the compile time or during the runtime. In the other cases
In
also.
compile time.
Yeah. In the case of queues,
It's dynamic.
runtime, right?
In runtime it will be allocated.
Yeah. In dynamic arrays also, it is
Dynamic.
during
Yeah,
runtime.
right. Runtime.
Okay. So these are the differences between the dynamic arrays, queues, and packed arrays or unpacked arrays, right? Now, um, now let's see. Let's consider the example of dynamic arrays and queues. So in these two types, if we declare, let's say, dynamic array dy n1, let's say the size of this dynamic array is 10. Okay. And we will not declare the size. So during the runtime, we will give the size dy1 is equal to new of 10. So the total number of locations will be equal to 10, right? And we will discuss about this packed arrays or unpacked arrays. So how can we declare this? In case of packed arrays, it is data type followed by number of locations followed by array name. Whereas in case of unpacked arrays, data type followed by array name followed by declaration. Okay. So in case of unpacked arrays, if I have declared 10 locations, it will look like this, right? Now, so in both dynamic arrays as well as packed arrays or unpacked arrays, I can declare the arrays like this and memory will be created like this, right? So in case of this dynamic arrays, let's say we have created 10 locations, but we have deleted the elements from the locations 10 and 9. Okay. So these locations will be empty, right? Or consider the second case. If we have inserted, if we have created, let's say, some 10 locations, but we have inserted only 5 elements. Remaining 5 locations are empty, right? Are you getting my point?
Yeah, I'm getting.
Yeah. So I've discussed two cases. What is that? Those two cases. The first case is if we have declared 10 locations, and if I delete any two elements from that two locations, then the two locations will be empty, right? Or if I create 10 locations and if I insert only five number of locations, then remaining five locations will be empty. Okay. So basically, what is happening is here the wastage of memory is happening. So memory locations are getting wasted. So in the two cases we have discussed now are examples of wastage of basically memory. Okay, so to avoid that, we are going to discuss about associative arrays. So how associative arrays are helping us to manage our memory efficiently, now we are going to see. Okay, so basically, associative arrays in system verilog provide a way to store the data where the index or the key doesn't need to be an integer and doesn't need to be consecutive. Unlike dynamic arrays or fixed size arrays, they are very useful when the index values are sparse or irregular, allowing flexible and dynamic data storage. Okay, so this is the definition of associative arrays. So we will see the keywords what are present in this definition. So associative arrays in SV provide a way to store the data where the index or the key doesn't need to be an integer. Okay, so the index or the key doesn't need to be an integer and doesn't need to be consecutive. Okay, so these are the two important points. So in case of dynamic arrays or in case of fixed arrays, what is the index? What should be the index value? It should be only integer, right? Let's say suppose dyn of, if we have declared any dynamic array of name dyn, if we want to access or insert any element with the help of index only, we will do that, right? So the index value should be an integer only. Okay, so the index value should be only integer. Is this point clear? This is obvious, right? So in the case of fixed arrays or dynamic arrays, the index is always an integer. Are you getting my point?
Yeah.
And the memory locations in the case of fixed size arrays or dynamic arrays are also consecutive, or also consecutive. That means if you create any dynamic array or fixed size array, what happens? The memory locations will be consecutive only. So this is the case of fixed array, and this is a dynamic array, let's say. So if you create any fixed or a dynamic array, the memory locations will be consecutive like this. That is, this is first location, second location, third location, fourth location, like this. The memory locations will be consecutive. Okay, and in case of fixed array also, the memory locations will be consecutive. Okay, so in this case, the in case of dynamic arrays or the fixed arrays, the memory locations are consecutive. Whereas in case of associative arrays, in case of this associative arrays, the memory locations are not consecutive. The memory locations are not consecutive. For example, one, if we create a associative array, there may be a location memory location 0 created, or somewhere there may be a memory locations 4 created, or there may be a memory location 4 created, or there may be somewhere a memory location 8 created. So like this, we can also create non-consecutive memories in case of associative arrays. Unlike the consecutive memory locations which are present in dynamic arrays or fixed arrays, the consecutive memory locations like this, we can also create non-consecutive memory locations with the help of this associative array. We can create what memory location we want, that memory location we can create with the help of associative arrays. Is this clear? Is the difference between the associative arrays and dynamic arrays queues is clear?
Yeah, it's clear.
No. So that is what it is written in the definition. So associative arrays in system verilog provides the way to store the data where the index or the key doesn't need to be an integer. Okay, this point we will discuss now, and doesn't need to be consecutive. This consecutive term which we have discussed now. Coming to the index, in case of associative arrays, in case of dynamic arrays, what happens? The index value should always be an integer. Or in case of fixed arrays or dynamic fixed arrays like unpacked and packed, there also integer should be, sorry, index should be an integer. right? Whereas in case of associative arrays, the index value, the index value can be integer, or it can also be a string value. Okay, so these two possible cases are po- uh, present in associative arrays. Whereas in case of dynamic arrays or fixed size arrays, index should only be of integer type. Okay, so this is the difference between the associative arrays and dynamic arrays and fixed arrays. Okay, now, so unlike dynamic arrays or fixed size arrays, they are very useful when the index values are sparse or irregular, allowing flexible and dynamic data storage. So this is the overview of associative arrays. So what is the first point? The index value need not to be an integer. In the case of associative arrays, the index value is not need not to be an integer. And what is the second point? The index value doesn't need to be consecutive, unlike the dynamic arrays or fixed size arrays. Okay, so this is the basic difference between the associative arrays and other type of arrays which are present in the system. Now, coming to the key features, the first feature is unconstrained indices. So associative arrays allow the index to be of any data type, such as int, string, or not enum. I'm not sure about this, not enum. So this flexibility makes them very useful for lookup tables or data structures where indexing isn't straightforward. Okay, and coming to next is dynamic storage. The memory isn't allocated until an element is added. The size of the array can dynamically grow as the new elements are added. So in case of associative arrays also, what is happening is we will not declare the size of this associative array during the compile time. So size is not declared during the compile time. During the compile time. Okay, so this is also a very very important point. So the size of the associative array is not declared during the compile time. So how does array size is decided? It is decided. So I will, by this process, I will show it diagrammatically. So let's say this is our associative array we have declared. So when we declared some associative array, there will be no memory allocated to this associative array. Okay. So what happens is during the runtime, when we insert any element into this associative array, then accordingly the memory will be created. For example, if we insert the data, the first data, let's say it is 5, then a memory will be created for this data 5. Okay, like this a memory will be created. And if we want to try to insert next data item, let's say it is 7, so another memory will be created for this data 7. So what is the size here? What is the size of this associative array in this particular example? Can anyone answer?
It's two only, right? Only two values you have been given.
Yes. Okay. So the size of this associative array is 2. Okay. So like this, the memory will be dynamically increased. So this is a very, very important keyword. The memory will be dynamically increasing. Okay. As we insert the elements, the memory will be dynamically increasing. Okay. And the memory will be dynamically decreasing. When it will decrease? When we remove any particular element from this associative array, the memory will be dynamically decreased. Okay, so these are the two important keywords. The memory will be dynamically increasing and the memory will be dynamically decreasing when we try to insert or remove any particular element from this associative array. Okay, now, and sparse indexing. So the indices of associative array don't need to be contiguous. You can skip the indices, making it useful when you don't need to store in every possible key. This we will see with help of coding. What is this? We will see. Now, coming to the syntax of associative array: data type, array name, index type. So this is a simple syntax. Data type can be int, logic, bit, anything. So in this case, I will take int. Array name, I will take example underscore array. And index type, I can take anything. For now, I will take integer type. So here I will put a star. So whether it may be of integer type or any other type, so the basic declaration of associative array is in data type followed by array name followed by a star. So this indicates it is an associative array. Yeah. Hello. Someone raised the someone raised their hand. Yeah. What is your doubt? Hello. Okay. So we will see an example. Let's say suppose in this example, they have declared a module called associative array example, and they're declaring an associative array with index of string. Okay, so indexing can be done with the help of a string. Okay, so int is a data type and marks is the name of the associative array and string is the index. So index type here is string. Index type is string. Okay, so within an initial beginning block, so this is runtime. Okay, we have discussed about runtime and compile time, right, in our previous sessions. So if you haven't watched it, so please watch that, what is meant by runtime and what is meant by compile time. So this is an initial beginning block runtime. So see here, we haven't declared any size of this array, and during the runtime only we are inserting the elements. So with the help of this string called allies, we are inserting an element 85. So 85 is corresponding to the string allies. Okay, and another string called bob, which is pointing to the value 90. So this bob will act as an index to 90, and another index called charlie will be pointing to the element 78. So instead of using the index as an integer, we are using the index as a string. Okay, so when we want to access the element, then we will use the same string which we have used to insert the integer. Okay, so in the display statement you can observe, so marks of alice, marks of bob, and marks of charlie. Okay, so what happens here, when we try to display, we will get the output as alice marks is, the marks of the alice will be displayed as 85. So when we call the data with the string alice, so the index associated with this value will be displayed, that is 85 will be displayed. So like this we can use the strings instead of integer. Is this clear? Is this concept clear, how we are using the strings instead of integers as index? Is it clear? Hello.
Cleared.
So if you want, I can explain it in another way. Let's say suppose, yeah, I will try to explain it in a diagrammatical way. So let's say suppose this is our associative array. Um, Here we have three locations. So instead of index as 0, 1, 2, index as integer type, we are having index as string values, Alice and Bob and Charlie. So what is the value corresponding to this particular index? That is 85, and corresponding to this index is 90, and corresponding to this index Charlie is 78. So if you want to access the number 78 from this associative array, what you will do? Associative array name, that is what is the name? Marks followed by index value, that is Charlie. then you will get the value 78. So like this, you can use the string values instead of integer values as index. Okay, I hope this is clear. So can we move forward?
Yeah, we can move forward.
Now coming to the use cases of associative arrays, now only we have seen sparse data storage when you need to store data that has sparse or irregular indices, and lookup tables. Associative arrays are ideal for creating lookup tables where you can quickly access the value based on the keys like hash mark. And sparse memories, associative arrays can model sparse memory structures where not all memory addresses are needed or initialized. We will see this particular example now. So let's say if we create a associative array int array, let's say star. Okay, wait a minute. Yeah. So let's say we have declared. We will declare one associative array. 1 minute. Int array of the index we will declare as int data type only. Okay. So the index is of int data type, integer data type. Okay. Now during the compile time, what I will do, sorry, during the runtime, what I will do, that is within an initial parent block, array of 3 is equal to, let's say 5, and array of 10 is equal to 12, and array of 13 is equal to 14. So can anyone tell me how many memory locations are there in this particular array? Any answer for this? How many memory?
Three locations.
Yes. So there are total 3 locations, right? So let me draw the locations. Here we are storing the data. Here we are storing the data. Is it correct? What I'm doing, what I'm drawing, is it correct? Is this representation correct? Hello?
Yeah, yeah, it's correct.
It's not correct. Okay. So,
It's non-continuous, right?
yes.
So it will be like three locations only.
Hmm.
The index of 3, 10, and 13. Yes.
Okay. So, remaining locations will not be created. Only the location 3, location 10, and location 13 will be created. Okay. So, this is the difference between the
Oh,
associative arrays and different other type of arrays. Like say suppose example, I have created a dynamic array like this int array underscore dyn. I've kept it empty, and within an initial beginning block, what I will do, array underscore dyn is equal to new of, I should give the number of locations explicitly, let's say 10. So 10 locations will be created and 3 elements will be inserted, and these remaining locations will be empty only. Okay, they will be created but they will be empty only, and only 3 elements will be inserted. But in the case of associative arrays, uh, you can actually create you can actually insert elements in a specific memory locations. Okay, is it clear?
Yeah, it's clear.
Yeah. So this is about introduction to associative arrays. So we'll see about the built-in methods which are present in the associative arrays in our next session. Okay. So that's all for this session. So if you're having any doubts or queries, you can stay and ask me, or else we can end this session. Thank you.